Okay, today we start with the new model, that's the fourth model, that's the what the we study what the okay, okay, as you all said in the right here program for the research system in the two ways, the gateway model and also we have in the data flow model also. For the writing a program in the gate level model, we studied about the basics, how to write the gate level model. Okay, for this we need for the lexical convention and also we studied the different types of data types also. Okay, today we see the and even we studied the and then we start written the program for the gate level model for the original marks and also full adder and also local counter. And similarly, we have studied the writing a program in the data flow model. For that, we studied the basic writing the program, how to write the program, then for the different types of data operators. For writing the data flow model description, we studied the different types of operators. By using the operators only, we written the program for the data flow model of this one mark, matrix one mark, and also two data carry to carry data like this. Similarly, in this model will study the basics for writing the program in the behavior model, behavior description. For this, we need the two statements here. One is for the initial statement, another is for the always statement. When using the initial statement and always statement, we will write the program. If only any programming in the initial statement and the always statement, then we can tell that program is for the this program is then for the behavior description only. Okay, we study the idea that how to write the program. Okay, for the behavior description, then for the statements, two statements, one is for the initial statement, another is always statement. It different types of initial statements. One is there to study, and also here we study the loops, for loop, equal statement, and all, and also we write the program for the same as before is 1 mark, 8 is 1 mark, and the 4-bit full 4-bit equal adder, equal counter, and also equal we study the calculate and direct generate also. Okay, in the today we start with the fourth model is the behavior description. In this we will study the two statements, one is for the initial statement, another one is for the always statement. Okay, in this initial statement and always statement, we will study the always statement, and also we will study the loops here. Loops and beta loops, for panel, and also here we will study the writing the program, the various model value, groups, 1 marks, and 8 is 1 marks. And also similarly to adder. Okay, sometimes in the examination they ask for writing the program for the full subtractor. Okay, full subtractor also. But we studied the for the writing a program for the adder, program to adder. But we are the concept we are doing the examination for the subtractor also. Okay, just I studied that code also. For the today start with the initial statement and about the always statement. Okay. Okay. Right here, say the example belongs to right the structure procedure for the structure procedure. Okay, we all is initially always stated that structure procedure. Again, idea is structure procedure. Structure procedures. structured procedures. What are the structured procedures? There are two structured procedures. One we call the initial step, another is what the always step. Structured procedures initial the always step is called what the structured procedure. What is the structured procedure? Okay, there are two structured procedures. One for the initial, another one for the always. Another one is always. Okay, the statement is can be written. Okay, these statements are the most basic statements in the behavior modeling. Okay, if you want to write the program in the behavior model, these are the very basic statements in the behavior model. Okay, inside the structured model, okay, these statements actually appear only. Okay, within this block, okay, within the block of the structured program, these three appear. It means here if you are writing the program in the behavior model, there you have to write the initial always and the always also. Okay, these are what the not a question. These are what the parallel. Okay, these are what the concurrent programming. This is what the concurrent programming. Concurrent programming. Okay, as you are studying the C program, this is what the C program was about the sequential. There is the step by step. Okay, all the program will not execute the parallel. Okay, the statement of the above which will execute one, then one the next step will be executed. But here the structured programming. What is it? Where programming the structured process will execute parallel. Parallel means for the concurrent. They will execute the parallel. Okay, but I am not programming the statement will execute the sequential. But my program very like program, I will write the program with a variable model, a variable description, will write execute the statements, will execute the statements concurrently, it will not parallelly. Okay, it will not wait for the always statement for before executing of the initial. If you have two statements as initial, there you will be execute the initial statement as a concurrent parallel. Okay, for sometimes you need to refer the initial statement two to three times. Let us take the initial statement one and also initial statement two and the initial statement three. And even the always we also relate to the at the type of order zero. At the type of order zero. Order type of order zero. This statement cannot be nested. Okay, one thing is there. This statement cannot be nested. Okay, this statement cannot be nested. Cannot be nested. Okay, this is a very important initial statement. Okay, this is what the structure program. There are two statements in the structure process. One is for the initial statement, another is for the always statement. Okay, one thing you remember, these are the basic building blocks of writing the program for the variable models. Okay, one more thing that these are the what our write the program variable program is the variable model. This is what we call as concurrent programming. Instead of the C programming is what the sequential programming. But our variable model is what the concurrent programming. Concurrent is nothing but the parallel programming. Parallel programming is what the at the same time of the zero start time, the main statement will execute the parallel. It will not wait for the another statement to execute. And also you have the time. Okay, this cannot be nested. One more thing is what this cannot be nested. Always statement and initial statement cannot be nested. Nested means what one or multiple there is initial statement connected with always statement in and one initial statement also always statement okay, always statement will initial statement before okay, you should remember initial statements are written first, then only always statement. Always statement is the initial statement it means here we cannot be nested here. We cannot be nested here. Okay, take the idea as a structural procedure. Take the idea as a structural procedure. There are two structural procedure statements in Verilog HCL. There are two structured procedure statements in Verilog HCL. In Verilog HCL, there are two structured procedure statements in Verilog HCL. First one is called initial. First one is called initial. Second one is called always. These statements are two more basic. Guess what? These statements are these two statements are the most basic statements in the visual modeling, behavior modeling. Okay, all other behavioral statements can appear. All other behavioral statements can appear inside these structured procedure statements. All other behavioral, all other behavioral statements can appear. Behavioral statements can appear. Behavioral statements can appear. All other behavioral statements can appear only inside these structured procedures. Only inside these structured procedures. ಯಾವ structured procedures are language environment or initial. This statements will write the behavioral statements. Okay. Without these statements, you are not able to write for the behavioral model. Okay. If you use the always then start writing the program of the model. Okay. Next one, Velar is a concurrent programming. Velar is a concurrent programming language. Parallel, okay, it is performed with a parallel programming. Velar is a concurrent programming language. Concurrent programming language. Unlike the programming language, unlike the C programming language, unlike the programming language, it is a initial or it is a sequential in nature. For our sequential nature, C programming sequential in nature. But while Velar is a programming concurrent programming language. This is what a concurrent programming language. Okay, next one. Okay, that is the next one. That means Velar is a parallel programming. Velar is a parallel programming. Each initial line each initial line always statements represents a separate activity flow. Represents a separate activity flow. This is what the activity flow. This initial statement will give you the initialize the programming or whatever the data is out in the initial statement will write. Okay, if you want to start my programming execution with the 0 second you have to mention there only. If you want the execution of that waveform, start the execution of the getting the waveform. You can mention that time here, time equal to 10 seconds then my milliseconds and all you can mention here. 1000 nanoseconds and all you can mention here. But the activity of the flow for the always write the initial statements are different. Let me know about the other one, this is also about the other one. We can write it next one. Each activity flow starts at simulation time is 0. Each activity flow starts at simulation time 0. Each activity flow starts at simulation time 0. Next point. The statements always by initial cannot be netted. The statements always and initial statements always and initial cannot be nested. Okay, cannot be nested. Okay, take an initial statement. Okay, take an initial statement. Initial statement that will take All statement. First we consider the initial statement. Initial statement. Okay. The statement inside the initial statement you can write for the initial block. Okay. Initial block. The statement inside the initial block. Initial statement. Initial statement we can say for the initial block. Okay. Initial block and also here we have the initial block always we have the multiple number of initial blocks. Then all the initial blocks starts executing the runtime with the time of 0. If you have the multiple number of initial statements, then always the initial statement starts executing or run at the run or execute start executing or at the run at the time of time of zero. If you have the initial statement with the 1, 2, 3, like this, these initial statements are start executing at the time of 0. It means here it is supporting concurrent programming, that means parallel programming. And also here another point, multiple initial blocks are each clock starts concurrent. And the execution of the once the execution of the first statement, the initial statement, another statement, and the third statement. We take the concurrently. For example, we consider one example here. Okay, even the parallel statements must be grouped using what the begin and end. Okay, initial statements are always will go with what the multiple number of execution at the same time. But other program, other statements will not take. But here the initial statement. If I have the initial statement 1, 2, 3, like this, these will start at the same time 0, time of 0 only. You can mention. Okay, that's why we whatever write the initial statement, those equal for the initial block. Equal for the initial block. Initial block. Model, okay, for example, consider the models. Okay, for example, model stimulus can have the force, yes or no? This happens to force will share the stimulus get only the force will be available for very program for writing the very program. Will not take the any support is allowed for writing the stimulus. For writing the stimulus, will not take the any force here. Will not take because we are putting the direct our program everything inside the simulation waveform purpose. It means we are executing the directly the program here. Here the outputs, whatever the outputs are there, those considered for the inputs. So that rest is for the output purpose, register purpose. The result will be stored. But here the consider one example here the x, y, A, B, and here but here mentioning what the initial. Okay, this was the writing the complete program in the initial step writing. There will use the initial start initial begin and end. Okay, begin is begin and end. We will write the initial as a equal to 1 bit of 1 and b equal to 1 bit of 0. Okay, here we can also mention the delay. What is that delay? 5 for the 4 interval response. You can mention. Similarly, you can write the one more initial block begin and end. What we are trying to do here is that we are setting the input value with the top of set as the 0 0 0 1 1 0 1 1. There we are writing the input combination over there. When the input combination is over, we can write everything directly. But if what is the multiple number of inputs, it repeats here the program value will start executing the different data. First ಯಾವ್ದು 0 0 1 1 1 ಈ ತರ ಡೇಟಾ ಇಟ್ಕೋಬೇಕು. For these initial for these setting the input data we need for the initial statement. For every set of input we need for the or there is no number of initial statement. If you have if I have the four number of four combinations of inputs, then I need the four initial statements. How many statements? Four. But these initial statements always not the different types also. Here he has mentioned here the five initial statements. If he has mentioned here five initial statements, four initial statements. He has not mentioned that definitely my initial statement starts with what zero time only, zero time. Okay, next one what you can write the delays of the you can take the 10 because this is the 8 5 you can take the 8 equals to 1 bit of the out of the 1 bit of 1 bit of 1 okay is lower in total the total is equal to 1 bit of 1 can say the combination of values here that is here the beginning and end in the initial block we have to mention the beginning and end by writing the program for the test page ಬೇಕಾದ್ರೆ beginning and end initial statement use ಮಾಡಿ number of initial statements will be more here but we cannot be next here we can take the these can take the inputs simultaneously with more parallel it is connected initial statement only ಎರಡು ಮೂರು ರೂಪಾಯಿ ಎಕ್ಸ್ಟ್ರಾ but it is giving output by the output away to the delay for the this was the 5 milliseconds and 4 milliseconds like this we have mentioned the duration over but the inputs these are the inputs it means here the initial statements are these are not okay initial that is the finish what is finish what is finish statement is not the tablet execution program